Hey guys, welcome back you all into the course, and today we're going to be discussing about understanding computer communication, which is a very crucial but also a basic topic which you need to understand in order to work in the IT sector. So let's learn about it today, and I'm Gulnur here, your Udemy course instructor. So let's move ahead and walk you through the PPT. And I will provide the PPT in the resources tab, so you can download it from there and revisit it whenever you want to do it. So yeah, let's move on. So communication is vital to the internet's functionality. Computers need to exchange information for tasks like browsing the web, sending emails, streaming videos, and yep, so we already know about all this. Let's move on to the next slide. Now let's talk about binary representation, the building blocks of digital communication. So did you know that computers only talk in zeros and ones? So let's talk about that. Computers use binary code to represent data. This system uses only two digits, 0 and 1. Each digit, called a bit, can represent a single piece of information. Either it can be a 0 or it can be a 1. Then we have bits and bytes. 8 bits form a byte, the basic unit of data storage. Like a bit consists of only 0 and 1, and a byte consists of 8 bits here. And encoding data, letters, numbers, and symbols are encoded into binary sequences. We will be learning how like the characters A, B, C are formed even though we only have zeros and ones as the digits. Then we have digital communication. Binary code enables computers to communicate by transmitting sequences of zeros and ones. Now let's move on to the next slide. Now let's understand the unary system. We have already understood the binary system in the previous slide, so now let's talk about unary numeral system, a simplified approach. The unary system is a simpler system than binary, using only one symbol to represent numbers. It's a foundational concept for understanding binary and other numeral systems. So here, like if we count with the help of our fingers, so let's say I have 10 students in my classroom. So if I want to count all of them, I will be counting them on my fingers. That will be a unary system. So simple representation uses a single symbol, often 1, to represent each count. Like we can make each finger count to 1. Then counting in unary, the number 3 would be represented as 1, 1, 1. Like I would have to raise 3 fingers in order to represent 3 children. Then we have limited efficiency, not practical for large numbers due to its space requirements. Let's move on. Now let's talk about ASCII, or if you might say ASCII character set, which is the standard for text encoding here, and it is the American Standard Code for Information Interchange. It is a standard for encoding text characters. It assigns a unique numerical value to each character, allowing computers to interpret and display text. So here I have a chart of hex and the characters and the decimal types here. You do not need to learn it, just go through it once. And we have the characters and the ASCII code. As I told you before in the slide, that we will be learning how characters like A, B, C, D, E, F and so on and so forth are formed. So the character A has the ASCII code of 65. The character B has 65 plus 1, which we get 66. Then the character C, we have 66 plus 1. Then we have the character small a, which has 97. Then we have small b, which has plus 1 again to 98. Then we have C, which has plus 1 again to 99. So this is the basic representation of how we represent the characters, and let's move on to the next slide here. Now let's see Unicode here, and let's focus on first the ASCII limitations. ASCII only supports 128 characters, insufficient for global communication. For example, like if you have only 128 characters, we can only represent like 1 to 2 languages at most, like English and one more languages. But if we need to support all the languages, then we need something better than ASCII. So let's talk about Unicode, which is much better than ASCII. So it expands the character representation. Unicode is a more extensive Remember this. Character encoding system, then ASCII, encompassing a wider range of characters from various languages and scripts. So there are some limitations as we have discussed before. Then we have the Unicode's expansion. Supports over 143,000, or I must say 1,43,000 characters, accommodating diverse languages and symbols. So just check the difference here. Here we have 128 characters, and here we have 1,43,000 characters. Then we have unified encoding. Unicode ensures consistent representation of characters across different systems. Let's move on to the next slide. I hope you're enjoying this course by now. Now we have discussed already about ASCII, we have discussed about Unicode, we discussed about binary, unary system. Now let's move on to some protocols. The first one would be HTTP, which is the Hypertext Transfer Protocol. This is the most widely used protocol. So as we have touched this topic, let me discuss something about, like, just wait for a second. As you may already know, we have HTTP. We have another one known as HTTPS. We have SOCKS 4. And we have SOCKS 5. Please understand it. We have SOCKS 5. So these are 4 of the main protocols that we can use, and HTTP is like quite unsafe because there is no S at the end, which represents secured. Then we have HTTPS, which is much more secured. Then we have SOCKS 4. Here is SOCKS, sorry for the inconvenience. Here is SOCKS 4. It is also quite unsecure when compared to SOCKS 5. I always prefer SOCKS 5 as your main protocol, as we can use SOCKS 5 during proxy chaining or something like that. So now let's move on to the next concept here. Hypertext Transfer Protocol is the foundation of the World Wide Web, which we also refer to as WWW. It is used for transferring web pages, images, and other content between web servers and browsers. So first, let's see a 3-step communication using HTTP protocol. So here, first step is request. A browser sends a request to a web server. Then we get a response. The server responds with the requested content. Then we have the data transfer. The content is transmitted over the internet. These are the 3-step communication which happens through HTTP. Now let's move on to the next slide. Let's discuss TCP. This is Transmission Control Protocol, and this is widely used in today's world. It is a reliable communication protocol that ensures data is delivered accurately and in the correct order. Please, I'm going to stress upon the fact that it is delivered accurately and in correct order, as when we would be discussing the UDP, then there is quite a difference between these. It's likely a postal service guaranteeing delivery. We have error detection. It identifies and corrects error during transmission. We have the sequence control, which ensures data arrives in the right order. And we have connection oriented, which means that it establishes a connection before data transfer. Let's move on to the next slide. Now, as I said, we would be discussing about UDP, which is User Datagram Protocol. So User Datagram Protocol is a faster but less reliable protocol than TCP. It's like sending a postcard, not guaranteeing delivery. What I told you in the previous slide, I told you that it guarantees delivery, but UDP does not guarantee delivery. This is the main difference between both of them. But UDP has a fast transmission which prioritizes speed over accuracy, suitable for real-time applications, but it has unreliable delivery, whereas data packets may be lost or arrive out of order. Then we have connectionless, doesn't establish a connection before data transfer. We are referring to the UDP. Now let's move on to the next slide. Comparing TCP and UDP reliability and speed. TCP and UDP offer different trade-offs between reliability and speed. TCP ensures accurate delivery, whereas UDP prioritizes speed. TCP is reliable, connection-oriented protocol suitable for applications like file transfer and emails, but UDP is a faster, unreliable, connectionless protocol, ideal for streaming audio and video and online gaming. So now let's move on to the next concept here, which would be the conclusion. Here, let's conclude the session, and I want to tell you about mastering the fundamentals of communication. Understanding the fundamentals of computer communication is crucial for appreciating the complexities of the internet. As to who might have thought that there is only 0 and 1 as the binary digits for which computer understand, and like who might have thought like HTTP and the difference between HTTP and HTTPS. By delving into binary code, encoding systems, and communication protocol, you get insights into the intricate world for digital communication. So I hope you enjoyed today's lecture. I will see you in the next one. Till then, take care and bye bye.